So in the last lecture, we seen that let G be the linear operator on a vector space V, and V is the direct sum of all the subspaces. Then there exists a linear operator. This one, even equal to so on Ek on V, such that this all these four condition satisfies. Then necessary and sufficient condition for the each subspace Wi is invariant under T is that T is commutes with each of the ER. Okay, so this theorem we proved. So today we will see the next theorem. Okay, and also we seen that if E is the projection on V, then I minus E. Okay, this operator, linear operator is again projection on V. Okay, that is I minus E bracket square is equal to I minus E. Now the next theorem. Okay, HS alpha side is similar. Okay, let T be a linear operator. Let capital T be a linear operator, okay, on finite dimensional vector space V for the field F. If T is diagonalizable, if this capital T is diagonalizable, okay, T is diagonalizable, and suppose this C1, C2 up to so on, these are the CK. Okay, CK are distinct characteristic vectors, characteristic values, sorry, distinct characteristic value of T. A characteristic value of T. Then there exists. Okay, then there exist K linear operators. K linear operators E1, E2 up to so on Ek. Okay, on V, capital V, such that first condition T is equal to C1 E1 plus C2 E2 plus up to so on, this is CK Ek. Okay, second one, I is equal to E1 plus E2 plus up to so on, this is Ek. Okay, and third one is ER into EJ is equal to 0 whenever I is not equal to J. Fourth one, each EI is projection on V. Is projection on V. That is EI square is equal to EI. Okay, and fifth one is range of EI. Is characteristic space for T. Characteristic space for T associated with Ci. Okay, associated with Ci. And conversely, if there exist K distinct scalars, if there exist K distinct scalars, C1, C2 and up to so on CK, and K non-zero linear operator, K non-zero linear operators E1, E2 and up to so on K, which satisfies the condition 1, 2 and 3. 1, 2 and 3. Okay, then T is diagonalizable. Which one? This one. 1, 2, and 3. If these three conditions satisfies, then T is diagonalizable. And C1, C2 up to so on Ck. And if C1, C2 up to so on, suppose these are Ck are the distinct characteristic values. Distinct characteristic values of capital T, and the condition 4 and 5 are also test satisfied. 4 and 5 are also satisfied. Okay, so this is the statement of theorem. Okay, पहा काय काय दिलं. Okay, counter statement आहे. Let G be a linear operator on finite dimensional vector space V over F. Okay, if T is diagonalizable and C1, C2 up to so on Ck are the distinct characteristic values of T, then there exists a K linear operator E1, E2 up to so on Ek on V such that this phi condition holds. Okay, जर T जर diagonalizable असेल तर हे पाच condition true होत आहेत म्हणून सांग प्रूव्ह करायचं. Okay, so in the previous theorem we proved this one, this one, this one, and this one. Okay, हा आपण प्रूव्ह केलेला नाही आहे फर्स्ट कंडिशन. Okay, so by previous theorem, here there is no need to prove again second, third, fourth, fifth. Okay, by assuming T is diagonalizable and C1, C2 up to so on Ck are the distinct characteristic values of T. Okay, we know that how the E1, E2 up to so on Ek on V are the linear operators on V. Okay, we know that Ei of alpha is equal to alpha I. हे असे exist होतं ते माहिती आहे. Okay, so here no need to prove again. There exists a K linear operator E1, E2 up to so on Ek and 2, 3, 4, 5 statement. Okay, so in the necessary part we are going to prove only this one. Okay, T is equal to C1 E1 plus C2 E2 plus up to so on Ck Ek. Okay, and in the sufficient part we are assuming this condition holds. Which one? Condition 1, 2, 3. Okay, in the sufficient part, in the second part, we are going to prove T is diagonalizable. Assuming 1, 2, 3 equation holds. Okay, जर equation 1, 2, जर हे statement जर true असतील 1, 2, 3 in the converse part, we have to prove T is diagonalizable. And if C1, C2, Ck are the distinct characteristic values of T, जर असतील तर equation 4 and 5 पण true होतं ते prove करायचं. Okay, any doubt in this theorem statement?
Yes, sir.
So okay, in the first part we are not going to prove second, third, fourth, 5 and E1, E2, Ek are the linear operators on V, that is projection on V. Okay, we proved in the previous theorem this one. So in this first part we are going to prove only this one. Which one? T is equal to C1 E1 plus C2 E2 and up to so on Ck Ek. Okay, so first write down all the given things. Suppose a linear operator T defined on the finite dimensional vector space. Suppose okay, a linear operator T defined on finite dimensional vector space. Okay, capital. It's diagonalizable. It's diagonalizable. Okay, here that this T is diagonalizable. Okay, in the first part. Okay, and C1, C2 up to so on Ck are what? Distinct characteristic values of T. Distinct characteristic values of capital T. Okay, now let again is W1, W2 up to so on Wk are the subspaces, characteristic subspaces associated with characteristic value C1, C2 up to so on Ck. Okay, with W1, W2 and up to so on, these are the Wks. Okay, and what be the characteristic spaces associated with associated with characteristic value C1, C2 up to so on Ck. That means W1 is spanned by C1. Okay, W2 is spanned by, sorry, W1 is the subspace corresponding to the characteristic value C1. That means whatever be the characteristic vector corresponding to C1, that belongs to W. Is it correct? Whatever be the characteristic vector corresponding to C2, that vectors belongs to W. Okay, any doubt up to here?
No, sir.
Okay, now, but we know that here we assume that T is diagonalizable. Okay, that means V is direct sum of what? Characteristic spaces of T. Okay, here we assumed that T is diagonalizable. Okay, T is diagonalizable. It means what? There exists a beta for V. There exists a basis beta for V such that each and every vector of that basis is the characteristic vector. Okay, so here the T is diagonalizable. That means if and only if this V is what? Is direct sum of direct sum of hmm, characteristic spaces of T. Sorry, characteristic spaces of T. Yes. Okay, that means it's what? V is equal to what? W1 plus W2 plus direction plus up to so on Wk. Okay, where W1, each Wi is the what? Characteristic spaces corresponding to C1. Okay, if it is diagonalizable. Okay, so here we are writing each Wi what? Characteristic space corresponding to Ci. Okay, and we have to prove that there exists k linear operator on, okay, a linear operator e1 e2 up to so on ek on v. Okay, so by previous theorem there is no need to do this one. Okay, how the e1 e2 ek exists on v such that each ei is projection and each I is equal to, we can write e1 plus e2. Okay, हा सोडून हा स्टेटमेंट हा सगळा प्रूव्ह केलेला आहे. Okay, how the each ei is the projection on v. Okay, okay, so here no need to prove. So for only we have to prove statement number one. Which one? To prove that t is equal to, first one, t is equal to c1 e1 plus c2 e2 plus up to so on, this is ck ek. Okay, any doubt up to here?
No, sir.
ओके, हे आधीच आपण प्रूव्ह केलेलं आहे आधी.
Yes,
सेकंड,
sir.
थर्ड, फोर्थ, फिफ्थ. ओके, हीच कंडिशन नवीन आहे ह्याच्यात. Now let alpha belongs to p, v be any vector. Let alpha belongs to capital V, be any vector. So we have what we have, I is equal to what? By second statement, I is equal to 1 plus 2 plus up to so on k. Okay, so that is I of alpha is equal to e1 plus e2 plus up to so on ek of alpha by this statement, second statement. Okay, this one. So this is equal to alpha is equal to summation I running from 1 to k ei of alpha. Is it correct?
Yes, sir.
1. Now operating t on both sides, we get operating t on both sides. So we get this is t of alpha. Okay, this t of alpha is equal to t of in the bracket summation I running from 1 to k ei of alpha. Okay, but t is what? Linear. That means this t of alpha is equal to summation I running from 1 to k. This t of ei of alpha. Okay, why? Because t is linear operator. Okay, give it as an equation number 2. Now, since what is wi? Wi is range of data. By this statement, this one. Right? Fifth one, na? Range of Vi is the characteristic space for Ti associated with Ci. That is Wi. Okay. So Wi is range of Ei. That means this Ei of alpha belongs to
WI.
Wi for I running from 1, 2, and so on. This is K. Okay, and what is Wi? Wi also this Wi is characteristic space associated with characteristic value Ci. That means this is the characteristic vector corresponding to Ci. Okay, that means this T of Ei of alpha, okay, is equal to Ci into Ei of alpha. Is it correct?
Yes, sir.
Okay, हा तुमचा Ei of alpha काय झाला? Belongs to W म्हणजे हा characteristic vector झाला corresponding to Ci. That means this Ei satisfies this condition. Okay, now give it is equation number 3. Now using equation 3 in 2. So putting the value of here. So T of alpha is equal. But we get T of alpha is equal to summation either 1 to k. This is Ci into Ti of alpha. Okay, without.
No, sir.
So this T of alpha is equal to T of alpha is equal to 1 summation this C1 plus C2 plus and of course this is CK of alpha. Okay, so that is T is equal to C1 plus C2 plus and of course this is CK. Okay, get out is the blue. Okay, so in the part 1, we include the this statement 1, T is equal to C1 E1 plus C2 E2 plus up to so on CKK, and by previous theorem, we do second, third, fourth, and fifth. Okay, तेच proof आहे ह्याच्यासाठी जे मागच्या theoremला लिहिलेलं आहे. Okay, now in the converse part, clearly we are going to assume that C1, C2 up to so on CK are the distinct scalar, and E1, E2, Vk are the K non-zero linear operator on V. Okay. In the converse part, we are going to assume K distinct scalar. Okay. And K non-zero linear operator, which one? E1, E2, Ek. Then we have to do that condition 1, 2, 3. Okay, मला माहिती नाही थे C1, C2 काय आहे, फक्त स्केलर आहे एवढंच माहिती. आणि E1 E2 हे काय नॉन झिरो लिनियर ऑपरेटर. Then we are going to do that 1 2 3 condition. Which one 1 2 3? First, second and third. Okay. आणि जर T हा diagonalizable ठेवला, then the T is diagonalizable and C1 C2 C are the distinct characteristic values जर घेतला तर काय condition 4 and 5 also true. Okay. Now next one, converse one. Any doubt up to here?
No, sir.
In the conversely, assume that conversely, assume that C1, C2 up to so on Ck are distinct scalars. Distinct scalars. Okay, and E1, E2 up to so on K are what? Are K non-zero linear operators on V. Operators on capital V. What is the meaning of non-zero linear operators on V? So there exist at least one. Okay, there exists only at least one. There exists at least one alpha belongs to V such that EI of alpha is not equal to 0. Okay, this is the definition of non-zero. असा एक तरी alpha exist होईल such that EI of alpha is equal to 0. Okay, so for all alpha belongs to V, that EI of alpha माझा 0 झाला तर काय होईल? EI is 0 operator. Okay, is it correct?
Yes, sir.
So here all the EIs are non-zero linear operators. That means at least one alpha exists belongs to V such that EI of alpha is not equal to 0. Okay. Conversely, assume that C1, C2, Ck are the distinct scalars and E1, E2 up to so on K are the K non-zero linear operators. Okay, on V such that okay, such that कोणते कंडिशन घ्यायचे कॉमर्स पार्टमध्ये first, second, 3. Okay, first, second, and third. And we have to show that T is diagonal. Okay. Operators on V such that first one, what is first condition? E is equal to H. E is equal to C1, E1 plus up to some this is CK, EK. Okay, second one, what is second condition? I is equal to E1 plus E2 plus up to so on EK. Okay, and what is third one? EI into EJ is equal to 0 where I is not equal to J. Okay, and what we have to prove? To prove that first A part A, B is diagonalizable. Okay, B part. What is B part? C1, C2 up to so on CK are what? Distinct characteristic value. Okay. C1, C2, another part. C1, C2, CK are distinct characteristic value. एक दो करेंगे. T is diagonalizable. एक दो करेंगे. Okay. And what is C part? This one. EI is the projection on V. Okay, fourth and fifth. And what is D part? D range of EI is characteristic space corresponding to the characteristic value CI. This one. Okay. हे तीन गोष्टी assume केल्या आपण. Second part, and we are going to prove this one is diagonalizable and C1, C2, CK are the distinct characteristic. Okay. C. What is C? EI square is equal to EI for all I. And what is D part? range of EI. Range of EI is characteristic space, okay, corresponding to characteristic value C1. Okay, these are the four things we have to do in the second one. Okay, first we are going to prove C1. Okay, what is C? To prove that EI square is equal to EI for all R. Okay, so let alpha belongs to V be any vector. Okay, alpha belongs to V be any vector, and we have what we have condition number second. What is second condition? I is equal to E1 plus E2 plus up to so on. This is E2. Okay, so that means I of alpha is equal to, do direct, alpha is equal to E1 of alpha plus 2 of alpha plus up to so on. This is Ek of alpha. Okay, operating EI on both sides again. Operating EI on both sides. Okay, with I on 1, 2, 3. Okay, we get EI of alpha is equal to EI into E1 of alpha up to some. Okay, the I as EI into EI of alpha plus up to some. This is EI into K of alpha. Is it correct?
Yes, sir.
Okay, so this is EI of alpha, which is equal to what is the value of this one? 0.
Zero.
कसा काय आला? From third condition, we assumption. Okay. Whenever I is equal to j, then it is 1. Okay. Whenever I is equal to j, then it is EI square alpha. Where I will become 1, 2, up to so on. Okay. Okay. That is EI square is equal to EI for all alpha belongs to capital V. Okay, is C part. Okay. Now we are going to prove the B1, B part. What is B? C1, C2 up to so on, Ck are the distinct characteristic value. Prove that C1, C2 up to so on, Ck. C2 up to so on, Ck are characteristic values. Okay. Kind outside काही बघा no doubt.
No, sir.
So now let alpha be any vector. Alpha belongs to be any vector. What we have operating T on both sides. Okay. Let's just wait. Alpha belongs to be any vector. So what is EI of alpha? We get EI of alpha is equal to this alpha be the any vector. So operating T on EI of alpha. Okay, each EI is the projection. That means EI of alpha is again to be. So here the operating T on EI of alpha we get. So this is T of EI of alpha, which is equal to, what is T? T is nothing but our first condition. C1, E1, C2 equal to so on, Ck. That is, that C is equal to summation I run from 1 to K. This is Ci into, instead of I take here J. Okay, Cj Ej of Ei of alpha. Is it correct?
Yes, sir.
So this is equal to summation J value from 1 to K. This is Cj into Ej into Ei of alpha. Okay, so which is equal to run J now. Okay, हा run J केल्यानंतर कुठेतरी हा I ला coincide होईल. I into E of alpha. So that value becomes Ci into EI square. EI square is what? E है ना?
EI.
EI of alpha. Okay, after running the J. So this value becomes Ci into EI of alpha. Okay, what is the reason? Since EI into EJ is equal to 0, whenever I is not equal to J. That means this P of EI of alpha is equal to Ci into EI of alpha for all I running from 1 to up to some K. Okay, so then wait, EI is not equal to 0 since okay, Allah have give it as an equation. But since EI is not equal to 0, what it means non-zero, right? EI is non-zero linear operator. Okay, what is the meaning of this one? This one K. So then there exists at least one non-zero alpha. It is or one non-zero beta belong to zero vector. Suppose this beta belongs to B such that EI of beta is not equal to 0. Okay, जर असं नसेल तर काय होईल? Otherwise, all EIs are zero operator. ओके, एकही जर मला बीटा जर एक्झिस्ट झाला नाही that EI of beta is not equal to 0. That means EI of beta is equal to 0. That means all EIs are 0 operator. Okay, is it correct?
Yes, sir.
So from 1, this is T of the non-zero vector. It is EI of beta is equal to what? Ci into EI of tau. Okay, for this one. Okay, हा तुमचा आतला आता काय झाला हा नॉन झिरो वेक्टर. Okay, from 1. Where I running from 1 to K and EI of beta is what? Not equal to 0. Okay, so this shows that C1, C2 up to so on Ck are what? Distinct
Characteristic.
characteristic values. Okay, of capital T. Okay, so here the C1, C2, Ck are the characteristic values of T. Now we have to show that C1, C2, Ck are the only characteristic value of T. Okay, that means other than this one, there does not exist any characteristic value. म्हणजे याला सोडून बाकी कोणतेच येत नाही. ते कॅरेक्टरिस्टिक व्हॅल्यूज हेच आहेत फक्त. हे आपल्याला प्रूव्ह करायचं. ओके, हे कॅरेक्टरिस्टिक व्हॅल्यू आहे प्रूव्ह केला आपण. Okay, here we prove that this C1, C2 up to so on Ck are the characteristics values of T. Now we have to show that these are the only characteristic. Okay, that means if C is the any other characteristic value of T, then that C is coincide with one of them. C1, C2 up to so on Ck. Is it correct?
Yes, sir.
Okay, पहा इथेच या पार्ट मध्ये बी पार्ट मध्ये काय प्रूव्ह करायचं? The converse part. C1, C2, Ck are the distinct characteristic values. Okay, so other than this, there does not exist any C such that that condition holds. Which one? This one. T of alpha is equal to C into alpha. Okay, now to prove that C1, C2 up to so on Ck are the प्रत्येक फरक are the only characteristic value. Is it correct? Pratyek, any doubt?
Yes, sir.
Okay, only characteristic value of T. Okay, now let assume C with the any other characteristic value. C any other characteristic value of T. Okay, such that C is not equal to C then. Or iron from 0, 1, 2, and up to so on K. Okay, what it means? That means C minus Ci is not equal to 0. So iron from 1 to K. Okay, now this is what C minus Ci is not equal to 0. That is non-zero. Okay, so then there exists non-zero vector. Okay, non-zero vector. माझा काय हा C minus Ci is the characteristic vector not equal to 0. Okay, so hence here C is the any other characteristic value other than Ci. That means C minus Ci is not equal to 0 for iron from 1 to K. So then there exists a non-zero vector alpha belongs to capital V such that T of alpha is equal to C into alpha, which is not equal to 0. Okay, so हा जर माझा characteristic value असेल तर एक non-zero vector exists. Is it correct?
Yes, sir.
Okay. What is the reason? Characteristic vector always non-zero. Okay. So now T of alpha. What is T of alpha? C1 into E1 plus C2 into E2 of alpha. Okay. On which condition? From condition 1. Okay. Okay. In this condition, T of alpha we can write C1 into E1 of alpha. Okay. C2 into E2 of alpha plus up to some. This is what? Ck into Ek of alpha. Okay. Now, this T of alpha we can write is equal to C into I of alpha. Okay, our conditional solution. Okay, so what is the value of this one? This is summation I running from 1 to K Ci Ei of alpha. What is this one? Right hand side. C into
C into alpha.
E1 of alpha plus E2 of alpha. Sorry. Okay. I म्हणजे काय तुमचा E1 plus E2 plus E3 up to so on Ek. Okay, so this is equal. Directly E1 into C हा प्रत्येक काय होईल हा तुमचा काय E1 plus E2 plus up to so on Ek. Okay, so this is C into E1 of alpha plus C into E2 of alpha plus up to so on this is C into K of alpha. Okay, that is. Any doubt up to here? कोई doubt है क्या?
No,
This
sir.
is C is equal I is equal to since I is equal to E1 plus E2 plus up to so on this is Ek. Okay, H value मुझे नहीं थी खाली. Okay, H value का नहीं. Okay, okay, H value. So this one is summation I will 1 to K Ci into Ei of alpha and What is this one? Summation. I have an form 1 to k c into pi of alpha. Is it correct?
Yes, sir.
So this implies summation I have an form 1 to k, which is ci minus c into pi of alpha is equal to 0. Due to equation number third. We have equation number 2. Okay. Now look at it. Ci minus c is not equal to what? 0. Okay. Okay. काय झालं हा रन आयरन करा c1 minus c into e1 which e1 of alpha. Is it correct? Plus c2
Yes,
minus
sir.
c into e2 of alpha plus up to some ck minus c. Okay, this is ck minus c of k of alpha is equal to 0. Okay. Now here c1 minus c is not equal to 0. This is not equal to 0. This is not equal to what? 0. Why? Look at it. Okay, for I running from 1 to k, this is not equal to 0. That means काय झालं प्रत्येक तुमचा ऑपरेटर 0 झाला याचा अर्थ. हा नॉन झिरो हा नॉन झिरो हा नॉन झिरो आणि बाकी सगळ्यांची ॲडिशन 0. दॅट मीन्स काय ईच टर्म 0 असेल तुमचा. इज इट करेक्ट?
Yes, sir.
Okay. So if second step, if all i's are bi of all bi of alpha are 0, then we get then we get contradiction. Okay, 2, 2. It's number 2. Okay, what is 2? Okay, there's it. तुमचा EI काय झालं नॉन झिरो असतो होता ना EI. All EIs are what? Okay, look at here. All EIs are satisfying equation here. Right. Wait. All EIs are non-zero. Okay. And here we get what? EIs of alpha is equal to EI of alpha is equal to 0. Okay, so this is the contradiction to 2. Okay, so then we must have this is EI of alpha is not equal to 0. म्हणजे हा तुमचा टर्म नॉट इक्वल टू 0 असायला. ओके, याचाच अर्थ काय हा 0 असायला. ओके ना, हा कशामुळे होतो ड्यू टू द रॉंग assumption. What is the wrong assumption? See with the any other characteristic value. This one is wrong. Okay, now operate EI on both sides. हा कसा प्रूव्ह करायचा now. Okay, with respect to this particular I, respect to this, which one is particular I, operate EI on both sides. On both sides. Okay, what we get then is EI of summation. Okay, then this j is equal to 1 to k. Okay, and this is cj minus c into काय जे घेतलं कळतं इथं आय आलं नाही. ओके, याच्यावर ओके याच्यावर अप्लाय केलं जे घेतलं आहे नोटेशन चेंज केलं. Why? Because here we are putting EI. So this is EJ of alpha, which is equal to EJ of EI of 0. This is equal to summation j equal to 1 to k. This is Cj minus C into this one is Ei into Ej. Why? Because Ei is linear of alpha is equal to what? This is linear operator means Ei of 0 is 0. This is implies. What we get here? After run the chain, we get Cj. Sorry. Huh. Whenever we run this chain, so this chain is coincide with I. Okay. 1, 2, 3, 4 other point. Makakawaliti the coefficient non-zero. Okay, so this is Ci minus C into this is Ei into Ei of alpha is equal to 0. Which is equal. This implies Ci minus C, which is Ei square, which is equal to Ei of alpha is equal to 0. Okay, but here what we get? Ci minus C is not equal to 0. Okay, that implies Ei of alpha is equal to 0, which is not true. Okay, why? Because each Ei is non-zero. Okay, which is not true. Because Ci minus C is not equal to 0. Kashamala has statement why we get this contradiction because Ci minus C is not equal to 0 and Ei of alpha Ei of alpha is not equal to 0. Okay, so this shows that there exists there does not exist sorry there does not exist any other characteristic value except C1, C2 equals 1, C2. Okay, so hence this C must be coincide with one of them Ci. Is it correct?
Yes, sir.
Okay, any doubt up to here?
No, sir.
Okay, I don't statement ahead that next lecture. Which one? A and D. Okay, we will do this one, B and C. Okay, it remains to do this one and this one. This will be two. We will see in the next lecture. Okay, any doubt up to here?
No, sir.
Okay.